Well, it looks like we've got most of our attendees in, so we can get started. Um, so welcome and thank you for coming. I'm Richard Graves. I'm the director of the Center for Sustainable Building Research at the University of Minnesota, and we lead the team that manages the B3 and SB 2030 programs. After I give a brief introduction, we're going to kick off the event with virtual recorded tours of three B3 projects. Then Chris Baker and I will announce the award winners of the B3 awards. And then Becky Alexander will give a brief update on what's new and what's next with B3 programs and tools. As a brief, the other thing I should say, sorry, a couple of logistics. We'll be recording this session, and so that recording will be sent to you, after the session if you want to follow up on anything. The videos we'll show will also be up and available for you to watch later. In addition, if you have questions or comments, feel free to put those in the chat as we go. And then in addition, if you want or need closed captioning, that's available. If you click on the live transcript button in Zoom, that will get you to the closed captioning. So as a brief overview, the B3 and SB 2030 programs and tools support sustainable buildings throughout their life cycle, establishing project-specific performance requirements during pre-design, supporting sustainable design strategies to meet these goals during design and construction, and tracking and improving actual performance during operations. During its 15-year history, approximately 2,700 people have worked on the design of B3 projects. And in addition, nearly 400 projects are enrolled in the B3 guidelines at various phases of design, construction, and occupancy. These projects are located across Minnesota and range from large stadiums to multifamily housing to small park buildings and transit stations. 197, almost 200 projects have been designed to comply with the SB 2030 energy and carbon standard, and these have been both new construction and renovation projects. Together, these buildings are estimated to be achieving over 1 million MMBTUs of annual energy savings. And just to put that into context, that's like eliminating all of the building emissions from the entire city of Stillwater. We've also evaluated occupant satisfaction within 60 B3 buildings using post-occupancy surveys, and the results of which are available on the B3 website. And finally, over 9,000 public buildings are tracking their operational energy use through B3 benchmarking, which is a tremendous achievement. So, and now I'd like to introduce our guest speaker, Aditya Ranade. He's the Deputy Commissioner of the Division of Energy Resources at the Minnesota Department of Commerce.
Thank you, Richard. Very happy to be part of this event. In addition to my role at Commerce, I'm also a co-leader of the Power Generation and Buildings Working Group in Governor Walz's climate change sub-cabinet. So our mission at Commerce is protect the public interest represented at various fora for the industries that we regulate and advocate for Minnesota consumers. So buildings is a very key part of that. Next slide. So along with Department of Labor and Industry, Commerce took on a building efficiency work group. And the report that resulted from this work group was published in December. And the conclusions of that are very germane to the work of B3 benchmarking as well as SB 2030. So I figured, in addition to welcoming you all to this great event, I should share where it's being used in the regulatory and legislative realm. Next slide. So this group explored various policy options, incentives, benchmarking, energy codes, but it really settled on the use of building energy codes as a way to drive energy use related emissions down from commercial and multifamily new buildings. Next slide. And the way we approach this, and Richard was very instrumental in guiding us in this direction, is where are we on this ZEPI performance scale and SB 2030 scale, and what corresponding ASHRAE standards can we choose as a model for the state. Next slide. So we had really two options, a stretch code for all the buildings or a voluntary option for some cities. So for the sake of simplicity, we settled on a uniform code. At least that was our recommendation to the legislators. Next slide. So our recommended policy option was a series of building code upgrades towards making the commercial and multifamily construction net zero by 2036. And House Energy Committee Chair Jamie Long has a bill that I believe is part of the House Omnibus Energy Bill that aims to do just that. In addition to this legislative path of upgrading these building energy codes every 3 years and in line with the SB 2030 targets, Department of Labor and Industry is pursuing a regulatory pathway to do that. And they recommended to the Construction Codes Council adoption of ASHRAE 2019 in December, and they have already begun the rulemaking process. Next slide. So we believe that adoption of this new pathway will change the trajectory that Minnesota buildings have been towards a faster decrease in emissions. And the work that this group has done in B3 benchmarking and SB 2030 standards in terms of real examples of buildings and how much do these technologies cost, all that information has been very helpful for us as we talk to legislators and answer some of their questions on this legislation. At this point, I would hand it back to Richard, but really appreciate the work that this group is doing, and we have found it very useful as we pursue these paths and as we take the next steps. Should this bill pass in further education, continuing to implement some of these things on the state's own buildings and so on. So back to you, Richard.
Great, thank you. It's exciting times to see this trajectory for the potential for a future energy code to support our climate change goals. Thank you very much. So in the past years, the Best of B3 events have been held in person in the Twin Cities. Last year's luncheon featured a tour of the Arlington Hills Community Center designed by HGA. And since the event is virtual this year, we have the unique opportunity to showcase B3 projects in greater Minnesota and buildings we wouldn't typically have easy access to tour in person for a luncheon. So first we'll tour Eastman Hall, which is a renovation project at St. Cloud State University.
Eastman Hall was built in 1929 as a recreation and physical education facility, located at the south end of campus next to the Great Mississippi River. Renovated in 2019, the decor and structure of its interior brings together smart architectural design and an appreciation for its historical past to create a versatile space to serve and educate our students. The thoughtful renovation of Eastman creates a new facility that integrates learning and services. It houses various units of the School of Health and Human Services and Student Life and Development. The facility offers a blend of learning spaces and classrooms with service areas for student health and well-being. This includes our student medical clinic, counseling and psychological services, Healthy Huskies You Choose program, and the Recovery Community programming. Several art installations and placards adorn facility walls, reminding us of the facility's historical roots. Its large windows lend opportunities to appreciate and benefit from beautiful river views. Our students and staff enjoy soft seating, inviting lounge areas to relax, read, and catch up on coursework. We have a welcoming lounge area that is one of the favorite gathering places for our students. As we enjoy the views of the natural environment, the facility's design and efficiencies is very much in line with our climate commitment. This forward-thinking project is also a result of a collaboration with the City of St. Cloud as it continues its comprehensive planning process, which includes consideration of the Mississippi River.
The Eastman Hall project is unique in that it is a collaboration with the City of St. Cloud and its comprehensive planning process, taking the Mississippi River into consideration and embracing it in our project. This project took a previously shuttered building, renovated it, and created a space that is dynamic, heavily used, and multi-purpose. The Eastman Hall building is now efficient because we renovated and remodeled the plumbing, the heating and cooling systems, as well as the electrical and low voltage systems. We also took into account the fire and safety systems of the building and upgraded them to code. Prior to the renovation, the FCI, Facilities Condition Index, of this building was 0.31. It is now 0. We also cleaned up about $3.8 million of deferred maintenance on the space.
Reusing an existing structure is often one of the most sustainable options. That's exactly what we did here at Eastman. We took an underused building that had previously been used for an athletic facility and physical education building and renovated it to be what it is today. We removed the pool that had been on the lower level, and there had been a gymnasium above that we actually added an additional floor to make more usable square footage. We replaced the existing single pane windows with high efficiency glass to maintain the views of the river while also increasing the ability to get natural daylight. From there, we also added insulation to the exterior walls, and we also included very durable finishes to help the building live into the future.
Eastman Hall is a state-of-the-art example of the integration of student services and programs in the School of Health and Human Services, providing thousands of students with health and wellness and interdisciplinary experiential learning. This building strengthens our ability to serve our students and our commitment to the development of the whole student. On average, we have 16,000 visits to the medical clinic, 3,600 visits to the counseling and psychological services, which is vitally important in serving the mental health and wellness needs of our students. 8,000 students utilize the You Choose and Healthy Husky programming, and 2,600 majors in the School of Health and Human Services are in this building at one point in their careers. Services in Eastman are made possible through our collaboration with Centricare Health and the Greater St. Cloud Development Corporation, thanks to our partners who help create a collective impact on the well-being of our community.
Great. And next up, we have Wilkins Hall at the Minnesota State Academy for the Deaf.
The Minnesota State Academies for the Deaf and the Blind were established in Faribault in southern Minnesota in 1863. The academies provide educational services intended to build skills and maximize the potential of deaf and blind students from across the state.
Each deaf child and blind child has access to education that is equal to their peers in any other school. The same curriculum, the same opportunities, and the same growth that each child deserves.
The Minnesota State Academy for the Deaf, often referred to as MSAD, serves roughly 110 students. The campus is comprised of 11 buildings, including 3 residence halls, where half of all students live during the week. In 2015, Cadet Architectural Group was selected to design a new dormitory, Wilkins Hall, the first new construction on campus in more than 50 years.
We paid extra attention to things like lighting, visibility, acoustics, and emergency alerts, because these details matter to the deaf community. In addition, because the project was funded by the state of Minnesota, Cadet had to meet BSV guidelines for energy efficiency, water conservation, and so on. In many instances, considerations for deaf design and BSV design overlapped.
Deaf students often rely on visual cues to navigate the world. Clear sightlines and good lighting play an important part in the success of Cadet's design for Wilkins Hall. Rounded corners and glass partitions enhance one's spatial awareness. Wide hallways allow friends to walk side by side and communicate using American Sign Language. Many design elements bring multiple benefits. Generous use of windows throughout the building enhances visibility and reduces overall energy use. Occupancy sensors shut off light fixtures in unoccupied rooms, saving energy but also signaling to outsiders whether a room is empty or inhabited. The Cadet team took care to select an HVAC system that was both B3 compliant but also low vibration. The system was installed in a mechanical room with an acoustically separated floor and as far from where students were sleeping as possible. For kitchens, baths, and laundry areas, Cadet chose Energy Star rated appliances, just one of many energy-saving measures that helped the project meet its energy use intensity target. To reduce water consumption, low-flow flush fixtures and water-saving dishwashers were selected. High-efficiency boilers and LED lighting help reduce the overall carbon footprint. The design also meets B3 requirements for waste reduction. Almost 20% of materials used in new construction were sourced from salvaged or reused materials. Almost 5% were bio-based materials like wood beams, and over 75% of construction demo waste was diverted from landfills.
Meeting BSV standards isn't easy, but for us as designers, the challenges were interesting. We felt like we were designing a facility that not only met the needs of the campus community, but also made the future a little brighter for all of us.
From day one, students have been motivated and really wanting to live here than any other dorm on campus. It's very accessible. The visual lines for deaf students and communication access is quite easily accessible. The design, the private bathrooms, and the student rooms, it feels closer to home than a traditional dorm situation. This provides the comforts of home in a place where students can socialize. The design of this building is fitting in very well.
Great, fantastic. And finally, the final project is the Fergus Falls Public Library.
The newly expanded and renovated Fergus Falls Public Library is thanks to a multi-year-long process. It was designed and built with community participation and leadership, guiding the way to a new and unique facility. Roughly doubling the size of the library, BTR architects worked alongside library stakeholders in the city, along with the full inclusion of a diverse set of library patrons and friends. This included young and old, artists and tech enthusiasts, environmentalists, business people, cultural groups, and readers of all interests. The new library was designed with a special focus on young people and their families, building for the future using sustainable practices, adaptability, and the efficient use of resources, emphasizing the character of both the community and local landscape. The form and materials of the library connect visually to neighboring buildings and local landmarks. New wood trusses that were added match the original timber roof framing. Preservation of memorable elements like these from the past enliven the experience of library visitors by connecting with history, while the new fully dimmable LED lighting fixtures call attention to the modern. Several relationships made Fergus Falls Library a success. For example, the partnership with local utility Otter Tail Power was formed to design for energy savings and a commitment to Minnesota's B3 and SB 2030 energy standard, which is meant to significantly reduce the energy and carbon emissions in Minnesota's buildings. Performance is measured in a number of categories, such as site, water, energy, indoor environment, materials, and waste. Fergus Falls Library utilizes a high-performance building envelope that will minimize heating and cooling loads on the mechanical system, while simultaneously providing for views to the outdoors and natural daylight throughout the interior. It does this with controls that dim the light fixtures automatically where the natural light is abundant. The sun control fins on the west-facing windows shield the interior from the glare and additional heat that arrive later in the day. The light shelves on the interior bounce light deeper into the building. Balancing the daylight through the building are newly added clear-story windows called light monitors. These face north in the vaulted ceiling, bringing daylight deeper into the building without additional heat. The landscape along the west face of the library acts as a stormwater collector that can redirect the water to the detention and treatment field that the city has created across the street. Stormwater isn't the only thing flowing underground, though. A new geothermal heating and cooling system runs beneath the east parking lot, which includes a loop of 24 wells running 300 feet deep. This system has helped the building be 52% more energy efficient than comparable buildings. The advanced heating, venting, and cooling system includes water source variable refrigerant flow systems throughout the library. This system uses small refrigerant pipes instead of large air ducts to move energy around, allowing for smaller plenum spaces and the vaulted truss ceilings. You'd probably walk right by it and not even notice, but this bridge carries all the refrigerant pipes from the equipment room to the rest of the library. The HVAC system also uses quiet and efficient electronically commutated motor fans, which supports the library's acoustic environment. The acoustic performance is also enhanced by discrete panels along the walls of the vaulted areas in the new children's library. The colorful wood slat ceiling and walls also integrate an acoustic mesh all along the path to the children's library. Another feature that would go quietly unnoticed is the use of environmentally safe carpets and adhesives that don't pollute the air in the library. And humans weren't the only living creatures considered at Fergus Falls Library. Bird-safe windows were added to the high-risk zones, like these corner windows. Children, teens, and adults of all ages are welcome in areas dedicated to reading and creating, playing and researching, connecting online and meeting in person. And at Fergus Falls Public Library, they'll be able to do so for decades to come.
Fantastic. So a big thank you to all the project teams who have worked so hard to provide these wonderful videos to our team, but also available on our YouTube channel on the website, so that you can find out more about the fantastic projects going on in the B3 program. And now we'll get started with the awards. So the purpose of the B3 Awards program is to recognize top sustainable projects and leaders in Minnesota. And we have the following award categories. B3 Design, the Indoor Environmental Quality Award alternates each year between workplaces and classrooms and labs. And for the first three categories, three finalists were selected by the B3 management team based on a predetermined set of criteria. Winners were selected by a committee that included the Department of Administration, Department of Commerce, and the Center for Sustainable Building Research. We are also celebrating winners in three best of B3 benchmarking categories selected based on their 2019 energy performance. So first up is the Best of B3 Design Award. Projects were excluded from consideration if they have been finalists in this category more than 3 times, were unresponsive to receiving a letter of non-compliance, have unjustified or unexplained variances from the requirements, and have suspicious inputs from the tracking tool, energy performance was not considered aside from the prerequisite due to the separate SB 2030 award category. So the first nominee in the Best of B3 design is the DNR area office, Glenwood. The DNR office in Glenwood is a new 9,000 square foot area headquarters, which serves as an office and information center for visitors to the Minnewaska Lake area. The project's sustainability goals were to achieve a net zero energy building that utilizes natural daylighting and maximizes the use of geothermal and solar potential on the site. The project uses pervious pavers, retention ponds, and native plants to reintroduce a more sustainable habitat that manages stormwater while providing other ecosystem benefits. Additionally, the project team used a daylight model to site and orient the building to maximize daylight while limiting the removal of mature trees on the site. Durability, longevity, and minimal maintenance requirements were priorities when selecting materials. Several of the building products take advantage of locally sourced materials, such as granite from local quarries and thermally treated ash wood siding harvested and milled in Minnesota. The next nominee is the Fergus Falls Public Library. Recently expanded and renovated, as we saw in the video, the Fergus Falls Public Library is the result of a multi-year community engagement effort to increase access for all ages and abilities, incorporate sustainable strategies, and skillfully embrace the character of the surrounding landscape. By utilizing a high-performance envelope, the project was able to provide natural daylighting throughout the building and minimize the load put upon the mechanical systems. Reuse of the library's timber vaulted saved valuable existing structures and provides a sense of warmth and familiarity to the space. Incorporated into the site was a careful consideration of pedestrians, helping to improve accessibility and safety, rain gardens, and native drought-tolerant vegetation to manage stormwater on the site. And the final nominee in the Best of B3 design category is the Richard M. Scholl's Family Foundation, St. Paul Opportunity Center, and Dorothy Day residence. The St. Paul Opportunity Center and Dorothy Day residence is the second phase of the Dorothy Day Place, a campus run by Catholic Charities that provides day services and permanent supportive housing for single adults, as well as basic medical services. The campus uses a stormwater management system which directs water toward courtyard planting and utilizes a downsized storage tank for excess. A combination of at-grade and roof gardens are used to increase the amount of stormwater that can be retained on site. Combined with strategies like maximizing data lighting and common spaces, the center and residence is able to greatly increase its efficiency and lower its impacts. Durability of materials was a main priority in selection, as were minimal maintenance requirements. Window placement was taken advantage of to not only provide sufficient lighting, but also to help residents maintain connection to the St. Paul area. And with that, the award for Best of B3 Design goes to the DNR Area Office, Glenwood. We can all give a round of silent applause on the webinar for the project. Fantastic job, and you know, a lot of we saw the slide of the project team, and you know, we should all congratulate you know, fantastic work by the project team for this project in B3 Design. So next up, we have the Best of SB 2030. So the finalist selection process for the best of SB 2030 involved finalists that were selected by CSBR among all the SB 2030 projects. They had to have the prerequisites of being beyond the construction documents phase and the B3 guidelines tracking tool, and the SB 2030 review need to be completed prior to operations. And considerations were design energy use intensity as compared to the SB 2030 energy standard, and operational data was not considered. Projects were excluded from consideration if they had previously won in this category, have been finalists in this category more than 3 times, were again unresponsive to receiving a letter of non-compliance. Why on earth would you do that? And show a design energy use intensity that is higher than the SB 2030 energy standard. So for the best of SB 2030 nominees, the first is the Fergus Falls Public Library. Fergus Falls Public Library is a finalist in this category as well. Since you've already heard about the library's overall approach, here we'll focus on its methods for carbon and energy reduction. The library's design team took advantage of local utility Otter Tail Power's Energy Design Assistance Program, as well as SB 2030 energy modeling to determine the best energy saving methods. In addition to a variable refrigerant flow, HVAC, and a geothermal loop system, the library features energy recovery ventilators, dedicated plug load monitoring, and large roof monitors that draw daylight into the center of the building. The Fergus Falls Public Library is projected to use 67% less energy per square foot than the average building. And here's the design team again. The next nominee in the best of SB 2030 category is the Richard M. Scholes Family Foundation, St. Paul Opportunity Center, and Dorothea Day Residence. The Opportunity Center and Dorothea Day Residence is also a finalist in multiple categories. So here we'll just again focus on the project's approach to energy use. Early design decisions allowed for the center and residence to be served by district energy rather than requiring the use of a central plant. Combined with the building's tightly sealed envelope and daylighting strategies, the design team was able to significantly improve energy efficiency from the beginning. Also significant is the strategic use of chilled beam terminal units for the HVAC system. The center and residence is expected to use 77% less energy per square foot than the average building of this type. And finally, the final nominee in the best of SB 2030 category is the Bell Museum. Located in St. Paul, the Bell Museum building at the University of Minnesota, the Bell Museum building and site are conceived in an innovative living diorama that integrates sustainable and energy efficient technologies with the story of Minnesota's natural history. The Bell Museum makes the most of the sunlight it receives through strategic window placement, with the majority of the windows having north-south orientation. Combined with a reconfigured VAV mechanical system, computerized controls, high-tech glass, and a photovoltaic system, the project is estimated to use 71% less energy per square foot than the average building. These energy strategies are complemented by a variety of other sustainability efforts, such as low-impact exterior cladding, an extensive rainwater capture system that help create on-site ecosystems which serve as demonstrations for Minnesota residents. And the award for Best of SB 2030 goes to the Richard M. Scholes Family Foundation, St. Paul Opportunity Center, and Dorothea Day Residence. Again, silent applause and congratulations to all the hard work by Catholic Charities and the design team on this fabulous project. So next up, we have the best of indoor environmental quality classroom and lab in the classroom and lab category. So the finalist selection process for the best of B3 indoor environmental quality projects that achieved high levels of occupant satisfaction in the Sustainable Post-Occupancy Evaluation Survey were designated as finalists by the B3 Post-Occupancy Evaluation Team. Prerequisites were the projects needed to have completed a post-occupancy evaluation survey and then achieved an overall IEQ satisfaction score greater than or equal to 4. Considerations were occupant satisfaction with indoor environmental quality of their primary work and learning spaces. Projects were excluded from consideration if they have, again, previously won the award in this category and have been finalists in this category more than 3 times. So the nominees in this category are the Mankato Clinical Sciences Building at Minnesota State University. The Clinical Sciences Building at Minnesota State University Mankato is a new construction that features flexible classroom space, improved clinical science laboratories, and a low-cost dental clinic. The building also provides ample group gathering spaces and hosts a diverse mix of occupancy types. To make it work, the building makes the most of natural lighting opportunities. Interior spaces were analyzed on an individual basis to determine thermal comfort, ventilation, lighting, and acoustic requirements, and the project received significant input from students, faculty, and staff regarding their needs for the building and desired experiences. Through the post-occupancy surveying, students reported satisfaction with all aspects of the building. As well, students indicated that they enjoyed the building's daylighting and versatility of classrooms. An overall score of 6.21. The next nominee in this category is the Health Sciences Building at St. Cloud Technical and Community College. Renovated from an existing hospital, the St. Cloud Technical and Community College Health Sciences Building is designed to house the college's medical training programs. The building houses both instructional classrooms and simulation areas for a variety of medical disciplines, making the most of the building's former purpose. In order to better suit educational needs, the Health Sciences Building was remodeled to improve visibility across rooms to support the ability to observe procedures. Significant to design strategy was to retain as much of the existing infrastructure as possible, an approach that reduced waste and cost and allowed for instructional spaces to accurately reflect real-world hospital conditions. Student post-occupancy surveying showed that students were pleased with the building's ability to meet their needs and that its resources enhanced their education. And then finally, the final nominee in this category is the University of Minnesota Herbert Hansen Hall. Serving the Carlson School of Management, Herbert M. Hansen Hall was designed to support the school's undergraduate and evening MBA programs. Because the building was selected to be a pilot project for the B3 guidelines, its design incorporates B3's sustainability practices while enhancing the school's existing brand. The 129,000 square foot structure's curved glass and steel facade and step massing allowed for natural light to penetrate deep into the building's interior. An expansive deck and coffee shop reach out to the surrounding buildings, while classrooms and gathering spaces are brightly lit and allow for unobstructed views from a variety of angles. Through post-occupancy surveying, students reported satisfaction with nearly all surveyed aspects of their classroom environment and indicated that both the overall facility and their primary classroom enhanced their learning experience and health. And the award for the best of indoor environmental quality classroom and lab goes to Minnesota State University Mankato, their Clinical Sciences Building. Congratulations. Again, please share your applause for work well done to show that not only are we doing projects in B3 that are meeting the sustainability, energy, and carbon requirements, but also addressing user needs along the way. So congratulations. And now I'll hand it over to my colleague, Chris Baker from Wildan, to go through the Best of B3 Benchmarking Awards.
Good afternoon. I'm Chris Baker. The B3 Benchmarking Awards, the winner selection process looked at organizations that have shown the greatest energy reduction over time across their portfolio of projects, and were selected as winners by Wildan with CSBR and the Department of Administration and Department of Commerce weighing in. The prerequisites that the energy use has been tracked for one or more buildings in B3 benchmarking for at least 2 complete years. And the considerations we took into account were a year-over-year improvement in the ratio between the energy consumption and the energy benchmark across the portfolio of projects, timely upkeep of data for building portfolio in B3 benchmarking, and normalizing for the size of building portfolio in B3 benchmarking. Next slide, please. The best of B3 benchmarking for local government goes to, next slide, the City of Roseville. The City of Roseville tracks energy use for 12 buildings, totaling nearly 230,000 square feet. To improve energy efficiency, the City of Roseville worked to retrofit lighting with LEDs in all municipal buildings. The city also started to track the energy consumption of 6 new park buildings through B3 benchmarking in 2018. This has prompted Roseville to ensure newer buildings have higher sustainability standards with less energy consumption. Further support comes from the city beginning the installation of a solar panel array on the City Hall campus in 2019, demonstrating renewable energy generation and reducing energy costs. The City of Roseville used 26% less energy than the benchmark in 2019, a reduction of 4% from the previous year. Congratulations to the City of Roseville. Our next category is the best of B3 benchmarking higher education. Minnesota West Community and Technical College, Jackson Campus. Minnesota West Community College at Jackson Campus tracks energy use for 8 buildings comprised of nearly 120,000 square feet. Much of the campus's success in benchmarking is due to strategic planning of retrofits and installation of LED lighting. To facilitate these goals, the Jackson campus partnered with current students to provide extra hands, develop goals, and provide a valuable learning experience for the students. In addition, the Jackson campus increased HVAC water and sewer system efficiency through close monitoring of facility use patterns and class schedules. Combined, this information allows for the Jackson campus to accurately allocate resources based on need, reducing natural gas, water, and electricity use. In total, the Jackson campus uses 31% less energy than the benchmark in 2019, a reduction of 7% from the previous year. Congratulations to Minnesota West Community and Technical College, Jackson campus. The next category of best of B3 benchmarking is public schools. And the winner is Pine Island Public Schools. Pine Island Public Schools tracks operational energy use for their elementary and high school, amounting to over 300,000 square feet. To improve efficiency, Pine Island underwent an overhaul of their steam heating system, including repair of water damage and conversion from a steam system to a hot water system. In the summer of 2019, air handling units and hot water heaters were replaced with new high-efficiency models in the high school building, and the majority of the lighting was upgraded to LED. Through these changes, the district uses 41% less energy than the benchmark in 2019, a reduction of 8% from the previous year. Congratulations to Pine Island Schools and all of our Best of B3 winners.
Thank you, Richard and Chris, for the presentations of the winners, and congrats again to all of the winners. These projects will be publicized on the Best of B3 website within the next couple of days. We wanted to finish out this event with a description of what's new and what's next with the B3 programs and tools. I'm Becky Alexander. I'm on the B3 project management team. So starting with B3 guidelines, over the past several years, we've been completing a comprehensive review and updates to the B3 guidelines with the intention of bringing the system up to date with the latest national standards and green rating systems, reducing the administrative burden for projects, and improving the sustainable performance of future projects. So version 3.0 of the guidelines was released in 2017 with several process-related improvements in addition to substantial revisions to the commissioning and materials and waste guidelines. Version 3.1 was released for projects starting pre-design in 2019 with substantial updates to the site and water and indoor environmental quality guidelines. Version 3.2 was released for projects starting pre-design in 2020 and includes updates to the energy and atmosphere guidelines. We recently released a revision to version 3.2 to provide a method for small buildings to meet the guidelines, and we'll dig a little bit deeper into that in just a minute. We're now working on developing a method for adapting B3's site and water guidelines to better meet the needs of projects with small sites, which will be addressed in an upcoming revision. And as usual, the B3 management team will be holding focus groups and requesting feedback on this from the entire B3 guidelines contact list. If you do have specific feedback that you'd like to share up front regarding the specific challenges or opportunities for small sites, please reach out to Pat Smith at guidelines@b3mn.org. In this next revision to version 3.2, we'll also be including new and updated recommendations for pursuing resilience strategies in B3 projects. So a little bit more detail on the recently released B3 small buildings method. This accommodates new buildings, additions, and renovations under 20,000 gross square feet by focusing on compliance with the highest impact guidelines. So it's intended to provide flexibility and additional pathways in order to meet the intent of the program and retain the environmental and health benefits. So a few examples include either revised requirements or alternative pathways for daylight and acoustic modeling, moisture analysis, bird safety, life cycle assessment, and environmentally preferable materials. That size criteria of 20,000 gross square feet aligns with the existing small buildings method for SB 2030 projects specifically. And that's a separate method that provides a simplified prescriptive pathway for small buildings to meet the SB 2030 energy standard. So kind of two parallel but separate methods there. And more information on both of those can be found at the B3 guidelines website. Moving on to SB 2030, the SB 2030 80% better requirement has now been in place for over a year now. Buildings starting schematic design in 2020 and beyond must use 80% less carbon producing energy than an average building in existence in 2003. That of course is up from the 70% requirement we've been using for the previous 5 years. So for building owners and design teams, this often means that energy efficiency strategies alone won't be enough to achieve program compliance, and that renewable energy strategies will often be needed. So in acknowledgement of this, the SB 2030 program now defines a hierarchy of renewable energy options. So starting with on-site or on-campus renewable energy, moving then to in portfolio for owners that have multiple buildings, before moving to renewable energy credits as a last resort. And this hierarchy is paired with an updated cost effectiveness criteria of a 12-year simple payback based on current economic factors. The SB 2030 program updates are supported by updates to the SB 2030 Energy Standard tool. A few years ago, this tool was updated to enable project teams to produce a design model that can be used for SB 2030 compliance, complete with strategies, installation values, efficient mechanical equipment, reduced lighting density. The tool is now updated to also offer solar energy as a strategy and to build in the cost effectiveness test. Additional features include kitchen equipment options, HVAC scenario templates, and enhanced visualizations of the results. And coming up in the next year, we'll have additional design strategies built into the tool, as well as some improved PV modeling capabilities. So we continually track energy trends in SB 2030 buildings and wanted to share some of these results with you. Our most recent analysis of nearly 60 projects in the left-hand graphic found that the average square foot of SB 2030 projects is designed to use 65% less energy than the average building and 24% less energy than required by SB 2030. And most of these buildings came in under the 60% better threshold, with a handful at the 70% better threshold. So that explains why this number isn't closer to the current requirement of 80% better than an average building. In the second two graphs, an analysis of 27 projects showing operational that are tracking their operational energy use data shows that 85% of these are operating at or below their SB 2030 energy standard. So each dot below that dashed line in the middle graphic represents a building meeting SB 2030 in operations, not just in design. However, as you can see in the far right graphic, about half of these projects are using more energy than predicted by their design model. So that could be the result of unforeseen operational changes, inaccurate design assumptions, and or inefficient building operations. So as it gets harder and harder to design to meet SB 2030, we anticipate additional challenges in operating to meet SB 2030. This really highlights, I think, the importance of strong coordination between the energy modeler, building designers, and building operators during the design phases, as well as really strong follow through during operations. Next, in B3 benchmarking news, this is the platform used by building owners to track operational energy and water use. And the platform continues to be enhanced with additional functionality. So new features include an all new interface and design, including an enhanced visualizations tab with new visualizations templates, updated carbon emissions rates, enhanced Energy Star integration for multifamily housing, and the ability to share access with other data owners. Currently under development is a revamp of the weather normalization algorithm, which will use heating degree days and cooling degree days to improve accuracy and provide additional insight into building specific trends. Projects that are using the Energy Efficient Operations program are successfully reducing energy waste, and we've recently deployed a new module in this program that enables building operators to quickly determine if their energy recovery system is working as designed. And the team is currently continuing to select additional buildings to engage in this program. So if you're interested in learning more, feel free to reach out to Garrett Moseman at the Center for Sustainable Building Research, or Russ Landry at the Center for Energy and Environment. In post-occupancy evaluation news, we had a little bit of a lull this year as surveys were on hold while most B3 buildings were unoccupied. But in the meantime, we have developed a new survey tool for libraries to determine the influence of the physical space on patrons, identify which elements of the library are most valued, and investigate the library as a place. This survey instrument is ready for pre-testing as soon as patrons return to libraries. And then we just wanted to remind you too that more than 50 post-occupancy evaluations are publicly available through the B3 POE library, with many of the findings summarized on the case studies database, which you have seen screenshots of throughout this presentation. So we really encourage you to check these out as you work on your next project to see if you can avoid some of the common privacy, acoustics, air quality, and lighting complaints that we've seen from building occupants. The B3 case studies database continues to be populated with additional projects. It currently includes 158, and it includes a snapshot of the compliance status of each project. So you can actually use the filter functionality to see the status of all of the projects associated with your organization or with your design firm, and then can zoom in to a specific project to determine the details. Finally, we continue to expand our B3 and SB 2030 training resources. We have a YouTube channel with stories from past Best of B3 award winners, and now have a training resources page on the B3 website with recordings of past trainings. Here you can see our recent training sessions on the B3 guidelines small buildings method, the B3 resilience guidelines, and an overview of the post-occupancy evaluation program. In the future, we'll also be adding new on-demand content like guidance documents and short videos describing topics such as agency contact responsibilities, variances, and submissions and operations. We're also continuing our virtual training sessions with a deep dive into the SB 2030, this time small buildings method, in May. So with that, I would like to thank all of the B3 team members and sponsors. Thanks to all of you for coming, for helping advance sustainable building design and operations in Minnesota. A really special thanks to St. Cloud State University, the Minnesota State Academy for the Deaf, and the Fergus Falls Public Library project teams for your incredible tour videos. And again, congratulations to the 2021 Best of B3 winners. Please feel free to post about this event on social media using the hashtag BestOfB3, and watch out for a post-event survey in the coming days. We'd really appreciate feedback so we know which aspects of this virtual format we should bring forward into future events. We look forward to seeing you all at an upcoming training or at next year's B3 program celebration. Thanks so much.